Mathematics 2, Chapter Integration. Tutorial question 26. Find the particular antiderivative of each of derivative that satisfy the given condition. A. Now the antiderivative of derivative is just simply you integrate the derivative. So in the case of A, the derivative is given as 5et minus 4. So you integrate 5et minus 4 with respect to t. Now integrate exponential will always get exponential back. Integrate a constant will give you additional t. Don't forget this is indefinite integral. You will have plus c at the end. Now your function of y yet to complete, you need to follow the given question. They ask you use the condition given. So what is the condition? They said that when your t is equals to 0, your y equals to -1. So we substitute in -1 equivalents to 5e to the power of 0 minus 4 times 0 plus c. Now 4 times 0 is going to be 0. E to the power of 0 is 1. 1 times 5 is 5. So you move 5 to the other side. At the end, you will obtain c equivalents to -c. -6. Hence, your y function will be 5et minus 4t minus 6. That's going to be the answer for A. Now, let's try to do B together. Given you dr over dx equivalents to 1 minus x to the power of 4 divided by x cubed. Now, the antiderivative of dr is basically you integrate your derivative. Now, 1 minus x4 over x cubed. If I try to simplify first without integration yet, I can separate the two, become x1 over x cubed minus x4 over x cubed. If you notice, right, 1 over x cubed can be written as x to the power of -3. Meanwhile, here you can simplify further, obtaining only x. And now it's become more simpler function. You can straightforward integrate the power function. Remember, the power will be added up by 1, divide by that power. Same goes here. You will go x squared over 2 dx. If I simplify further, in nicely manner, please remove the dx once you have integrated. At the end, don't forget to put, correct, you have to put plus c, arbitrary constant, because this is indefinite integral. So your solution will be -1 over 2 x squared minus x squared over 2 plus c. Now use the given condition. What is the given condition? It's mentioned that when your x equals to 1, your r is equals to 4. Now substitute in 4 equivalents to -1 over 2 1 square minus 1 square over 2 plus c. At the end of the day, you will obtain c equivalents to 5. Now you can rewrite your final answer of Rx as -1 over 2 x squared minus x squared over 2 plus 5. That's the answer for part B. Now let's erase all of these and proceed to find C and D. Now C, find the antiderivative of dx over dt. Okay, so you will have xt equivalents to integration of t 3 over 2 because you have square root t cubed. So I'm going to change into indices. T to the power of 3 over 2 minus t over the same thing, t power of 3 over 2 dt. Now before I integrate, I'm going to simplify this function. If you notice, the first term can be further simplified, making it as 1 only. Meanwhile here, this is t to the power of 1. right? If you bring the same base together, if you bring it up, the power will be deducted, right? So 1 minus 3 over 2 will give you, correct, it's going to be negative half. Now you do not integrate yet, you just simply simplify. Now you perform the integration. Integrate 1 will give you t. Integrate t to the power of negative half become t to the power of positive half divided by positive half. Don't forget to put plus c at the end. So your final answer will be t minus 2t half plus c. Now this is your xt. However, since you still have an arbitrary constant, make use of the given condition. They said here when t is equals to 9, your x is equal to 4. So it becomes 4 equivalents to 9 minus 2, so 9 plus c. So at the end of the day, you will got c equivalents to 1. So your final equation of RT will be t minus 2 set t plus 1. This is the solution for C. Now, how to do D? A very simple process. Follow exactly the same thing. They give you derivative of p, which is your p prime. You want to find the antiderivative, meaning you integrate your derivative 10 over x cubed dx. Now if I rearrange it by bringing the power up, so it becomes negative power now. So I can perform a very simple or direct integration. The power will be added up by 1, so it becomes negative 2 divided by negative 2 plus c. So your p function can be written as negative 5 over x squared plus c. I bring back the negative power down. Now since c is arbitrary constant, I can find by using the given condition. It's mentioned when my x is equals to 1, my p is equals to 15. So 15 equivalent to negative 5 over 1 square plus c. At the end of the day, my c equivalent to 20. So you can find your complete function of px, which is negative 5 over x squared plus 20. That's all for question 26.